So, have you ever wondered why a compressor fails? We're here to show you the most common failures of compressors and their possible causes.
Watch this video carefully and take advantage of this training. Well, Peter, so are all these compressors defective?
Actually, Mark, we'll have to check all of them because sometimes we also find compressors without any defects. Today we'll check the defects reported and understand what the cause of the failure is. But as you already know, Mark, Embraco has a strict quality system. We have a specialized quality engineering team, and all our compressors undergo numerous tests during production. The selection of raw material suppliers is also quite strict in terms of quality. So Mark, most failures presented here are due to problems with the application or improper installation.
But doesn't Embraco provide a video that teaches how to correctly change a compressor?
Excellent, Mark, and that's why all the steps in this video should be followed correctly. Let's start with this one here then. I checked before, and this compressor has no defects.
What do you mean, Peter?
You see, the compressor is one of the elements found in the cooling system. When a malfunction occurs in the system, often the problem is attributed to the compressor. But before you remove it, it's necessary to check the electrical wiring and the cooling circuit. Look for a dented tube or cracked insulation, dirt around the condenser in order to identify if the problem really is in the compressor. And also, before removing the compressor, we must check the electrical components. Remember the video about changing compressors, right?
Oh, right. So how do we check if the compressor isn't defective?
First, we check the ohmic resistance of the windings and compare it with the information on the datasheet. Now let's turn on the compressor and check for noise and compression. Confirmed, the compressor isn't defective.
Wow, it's really important to check these items before removing the compressor. So, in this case, would it be enough to just replace the faulty component?
No, Mark. Embraco recommends replacing all the electrical components regardless of which one of them is defective, because the failure can be linked to a malfunction of another component.
Oh, and the second one here?
One of the common problems is related to the presence of moisture in the system, which can occur in various ways. One of them is through a poorly done vacuum process. This process is extremely important and must be taken seriously. A vacuum pump suitable for this purpose must be used, with capacity greater than or equal to 5 CFM.
Yeah, I've seen some technicians using another compressor to do the vacuum process.
Unfortunately, that's quite common, Mark, but a compressor isn't able to reach the recommended vacuum level, which is 500 microns of Hg.
Right, and what's the vacuum time required to remove all moisture from the system?
The ideal is to have a vacuum pump with a pressure gauge and ensure that it reaches the recommended vacuum level. Generally, the vacuum time varies from 30 minutes to 1 hour, depending on the size of the system.
But Peter, isn't the filter dryer's function to remove moisture from the system?
Actually, Mark, the vacuum process, if properly executed, will remove almost all the moisture in the system, and the filter dryer will remove any residue that might still be present. This is the second problem related to moisture in the system, since the filter dryer must always be changed together with the compressor, paying attention to the filter type recommended by Embraco for each refrigerant.
Got it. And what can this residual moisture cause in the system, Peter?
The carbonization of the valve plate and the compressor head, Mark.
Can the refrigerant fluid have something to do with a moisture problem?
Well, if the refrigerant fluid doesn't have adequate quality, it may contain residues or impurities from the manufacturing process, such as non-condensable gases and moisture, which can indeed be sufficient to contaminate the system.
Oh, besides these, is there any other way for moisture to get inside the compressor?
Yes, there is, Mark, and this might happen with leakage in the product's tubing on the low-pressure side. When this happens, it's possible that air infiltration occurs in the cooling circuit through micro holes, and together with the air comes moisture. If leakage occurs in the high pressure end, the problem will be identified with the loss of product performance. So Mark, have you ever seen the difference between a compressor with moisture and a compressor without moisture?
No.
I'll get them closer so that you can see them better. Sometimes compressors even show up here in the lab with water, but then we can't even confirm that it's just a moisture problem. In cases like this, the compressor might have been improperly stored before its shipment to Embraco. It's important to cover the compressor's connections to prevent the entry of water, dust, or other debris after being removed from the system. In this way, we will be able to actually identify the cause of the defect.
This lubricant oil seems to have a different color, doesn't it?
Let's compare them. This oil had its chemical composition altered. In abnormal operating conditions of the compressor with very high temperatures, the oil flowing through the compressor comes in contact with the discharge chamber, the warmest region of the compressor, degrading its chemical properties, making it darker and reducing its lubricating capacity. That's why it's important to ensure that the specified overload protector is used.
This reminded me that the oil can degrade more quickly with contaminants in the circuit, such as moisture coming from microleaks, a vacuum process poorly performed, or poor quality refrigerant fluid, which act as catalysts. So we can say that this process impairs oil lubricating capacity and the compressor's performance?
That's right.
Speaking of chemical reactions, I've heard of people adding antifreeze to the compressor. Can this cause a problem?
Yes, Mark, the problem is that the antifreeze, being an alcoholic solution, as it's added to the cooling system, chemically reacts with plastic components inside the compressor, making them fragile and brittle, compromising their quality and durability. Furthermore, it may generate changes in the chemical composition of the oil, causing it to lose its lubricating capacity.
May I take a look at this one?
Sure. What are you looking there?
Wow, Peter. Now that we're talking about lubricant oil, I have the impression that in this one here, there's less oil, isn't there?
It's true. Compressors leave Embraco's factory with the ideal oil charge for flawless performance. What happens is that during the cooling cycle, the oil mixes with the refrigerant fluid, causing a fraction of the oil to circulate through the cooling system and back to the compressor. But when there's an obstruction in the tubing or problems in the system's sizing, the oil can't return, causing the charge to be less than ideal for the compressor's optimal operation.
What would these sizing problems be?
Very long and narrow tubing, siphon in the tubing, evaporator inlet from bottom to top,
And if the compressor is operating with a lower than ideal oil charge, will it present problems?
Yes, Mark, when the compressor operates with an oil charge lower than specified, there will be increased wear, which can reduce the useful life of the compressor and could create a locked rotor situation. Take a look at this wear.
The wear is really visible, Peter. I understand. If the oil circulating in the system doesn't return to the compressor, problems will occur. So this means that good sizing of the tubing and cooling system is critical for the oil to return to the compressor. And are there any problems involving excesses?
Good question, Mark. There's one related whenever there is an excess gas charge, causing the rupture of the cylinder cover gasket or damage to the valve plate. Please hand me this compressor.
This one?
Yes, Mark.
So, if the gas charge isn't done using a suitable machine, precision scale, and metering bottle, we can overcharge it. Why does the gasket rupture?
Because, Mark, the gas overcharging leads to fluid return. Since the fluid is incompressible during the compression process, this generates an excessive load on the gasket, causing it to rupture. Let me show you another situation.
In this damaged valve plate, is it related to excess gas charge?
That's it! This warping or breakage may be related to excess gas charge, and in some more severe cases, the valve can break. But it might also be the incorrect compressor used. For example, a low back pressure compressor, LBP, being used in the system for medium or high back pressure, MHBP.
Oh, for this reason, it's important to always use the suitable compressor for each system.
Yes!
Taking advantage of this opportunity, Peter, if the compressor suffers some impact but doesn't show any apparent damage, does it still work?
Mark, although the housing is made of steel, the compressor should be treated with care, since the impact can cause severe damage to internal components, even if the housing isn't dented.
But doesn't the compressor have springs to absorb impacts?
Internally, the compressor has shock absorption springs and is tested to withstand normal shocks during shipment of the compressor or refrigerator. Now, excessive impact may damage the compressor's radial clearances, causing it to not work properly. Do you want to see it? There's a minimal radial clearance between the stator and the rotor. This blade should pass loosely through the stator and the rotor, but it's blocked here. If the compressor stops running from a fall or impact, the main cause of the damage is related to neglect in shipping or storage of the compressor or refrigeration equipment. Incidentally, when the compressors are forwarded to Embraco for defect analysis, it's essential that they be properly handled and stored. They can't be thrown, turned over, or shaken, as well as also be sent together with the electric kit used and its tubing plug to prevent contamination. It's a lot of information, Mark, so did you get it?
Yes, it was a great lesson. Thank you, Peter.